So I'm going back to, I think it was that first page, section 413. It asked for the proof. We put a trapezoid in our circle. Yeah, this one took me a moment, and I'm not afraid to admit that I basically woke up with an epiphany. Let that be a lesson to you all. Sometimes your best solution is to just back away. The simple truth is your brain continues to ponder problems and things that you've seen in your sleep. That is why sleep is a very powerful tool and necessary. I'll show an excerpt of that for you all in a little bit. However, let's get to this problem and prove what we want to prove. So I'm not going to write out the whole paragraph just for the sake of time, but I want to talk through the steps. If we are going to call this isosceles, we want to be able to say that the segments, these two, are the same. And if we're going to say those are the same, we could also talk about that their inscribed angles are the same. Base angles are the same. Because if base angles are the same, then opposite sides of our trapezoid are the same. So here's the trick for this particular problem. I'm going to start off by realizing that I get the opportunity to draw in a diagonal. Okay? And when I draw in that diagonal, I get, because of parallel sides, that alternate interior angles are the same. So far, so good. I can also draw in a second diagonal. And with this second diagonal, I also get that alternate interior sides are the same. Now at this point, I have single tick marks and double tick marks because it is not a guarantee that these angles are the same until we know that we're inscribed in a circle. Because here's the special detail. If I follow angle A, which is an inscribed angle, and I know I should say 3 letters, so we'll say BAC, is it not true that it has this arc for its intercepted arc? And I can do the same thing with BDC, which has the same arc as its intercepted arc. And if we know that inscribed angles are half of their intercepted arc, well then two angles that share the same arc must be the same value, which means you get to say that angle BDC is the same as BAC. And if I add a double tick mark there, then I have to add a double tick mark down here. And so now this argument about them having the same intercepted arc is now mirrored on the other side, because now ABD has intercepted arc AD, and ACD has intercepted arc AC. And if we take a look, we got all these double tick marks, which means I know that this intercepted arc over here, B to C, is the same as this intercepted arc, A to D, which means all these various angles are the same, which means that we can say with confidence that AD, this chord, is congruent to chord BC. Partly because if the arcs are the same, the chords must be the same. So for example, if I came over here and said that this arc was 80 degrees, and I came over here and said this arc was 80 degrees, then it would follow that those chords must be congruent. That's the only way that that can happen. So it's a little bit of a roundabout way, but it's kind of clever because it's using those inscribed angles, hence why it's on the inscribed angle page, but it does take a little bit of finessing. So I encourage you to maybe draw that picture and see if you can talk through those steps on your own, writing out a little bit more than I did, because obviously I pretty much just talked through the picture and didn't actually write anything down.